All right. So the lesson for today is called logistic regression. This is one of the famous and uh, most effective algorithm for machine learning. This is also supervised learning. So this is a continuation of the supervised learning series that we have last time. But last time, it's more of prediction. So the difference of linear regression to logistic regression is you're going to use linear regression for prediction of continuous values. When I say continuous values, the numbers are unlimited. So based on the facts or historical data, you can actually predict a number, let's say the house prices. If you have some features of previous data of the house prices that were bought and sold, the prices can provide us predictions of the average house price located to different parts of the nation or the country. So having said that, there are different other problems that can be solved by prediction, but not the problem of classification. So now we are gearing towards classification. So what are problems that are classified to be under classification? So these problems are like you're going to choose from two objects where two objects are kind of like identical, and you don't know uh, what can be the, let's say, you don't know how to choose it manually or using your own self knowledge. So you might be able to use some kind like a computer to let you choose from these two types. So it can be classification of different objects such as oranges and apple. So what are the sub cases of classification? Let's say flowers. Flowers has also different kinds of species, but they are kind of like different in a subtle way, a subtle way. So in order to be expert on choosing the best classification, you need to determine different kinds of features and use that as a way to train the machine, and the machine will classify the, the object. So logistic regression is a good model for identifying two types of classification. So these two types of classification, we call them binary classification. So what are examples of binary classification? Let's say you have an email, you receive an email and you don't know if the email is legit or not legit. So you can perform a classification solution to identify if the email is a spam or not a spam. Spam means this is being sent to a lot of people. So it's like a mass sending of information or invite to do phishing or information phishing. Okay? So classification is as simple as dividing waste. We save the easy algorithms for last. So What is actually linear regression? It's a classification algorithm that is used where the response variable is categorical in nature. The idea of logistic regression is to find a relationship between features and probability of a particular outcome, where we have to predict if a student passes or fails in the exam. When the number of hours spent studying is given as a feature, the response variable has two values, pass and fail. This type of problem is referred as binomial logistic regression or binary problem that can be solved by a logistic regression, where the response variable has two values, 0 or either 1, or pass and fail, or true and false. So there is also a multinomial logistic regression deals with the situation where the response variable can have three or more possible values. So we will study that later, different kinds of data sets for binomial logistic regression and multinomial logistic regression. So why logistic, not linear? Okay, so one of the limitations of linear regression is it cannot perform well with classifications such as binary classification or multinomial classification. That's why scientists develop this algorithm, this machine learning algorithm, to to determine these types of problems such as binary classification. So what do I mean when I say binary classification? So let X be some feature and Y be the output, which can be either 0 or 1. So what does that mean? It's the same thing with linear regression or prediction that you will have many X or many features, and then you need to have an outcome. You need to have a Y output. But the Y output is not a continuous number, but it's either 0 or 1. So that determines if this is a classification problem or not. So the probability that the output is 1, given its input can be represented as P, Py equals 1, or the input variable X, the probability that X is a Y1. All right. If we predict the probability via linear regression, we can state it as B sub naught plus B sub 1 X, something like what we have learned before from our linear regression. And then where X is the probability of 1. So linear regression model can generate the predicted probability as any number ranging from negative to positive infinity, whereas probability of an outcome can lie between 0 or 1. So only means that the linear regression model has a limitation to determine 1 and 0 because uh, it has a unlimited or infinity positive and negative values. All right. So it will the linear regression will miss some of the points. And when it misses some of the points, it might lose its uh, precision in identifying the class. So it's really sad. Also, linear regression has a considerable effect on outliers. To avoid this problem, we need to use log odds, or the logic function is used. Okay, so basically, logistic regression is a regression, but we will use the log odds function. So the log odds function is a mathematical model that will get the probability that it's either one or it's either zero. So the logistic regression came, or the reason why it's called logistic regression, because of the logit function or the log odds function. So it serves as the regressor to determine if it is zero or one. So the logit function is represented like this. So when you generate the probability, if it is uh, close to one or close to zero, you will now put that on a linear fashion. Okay. So where the left side calls the logit log odds function is called odds. The odds signifies the ratio probability success, probability failure. Therefore, in logistic regression, linear combination of inputs are mapped to the logit odd, and the output being equal to one. If we take an inverse of the above function, we get the x value. For us, the x value will be determined as like the sigmoid function. So the sigmoid function tries to determine if it is from that classification or not. So this is the sigmoid function. Okay. So the sigmoid function tries to know the 0.50 or the middle. As you can observe, there is a blue line on the S-like curve. So the S-like curve means that these are these points close to the line reaching for it has the higher chance that the class are uh, denoted as one because it's close to one. If you will look at the left side of the y-axis, yeah, and then so how do we determine if this is a good logistic function? If the points are gathering, which the sigmoid line is close to the dots. Ayan. Anyway, that is just me explaining it visually. Pero in most cases, if I'm going to be using it for my program, I only need to know the accuracy number of this model. I don't really need to I'm not going to explain it to the stakeholders because the stakeholders most of the time they are not inclined mathematically. So what does that mean? If you want to learn more about logistic regression, you might want to study the logit function and the sigmoid function for the reason that you might want to create your own algorithm and develop something that is similar to the sigmoid function. That's the only purpose for that. But basically, we need to have a regression from the probability features. And then, for us to know the performance of the logistic regression model, we need to have a truth table from the confusion matrix. So there are true positives and there are false negative, and there are false positive and true negative. And we were going to test that from the actual and from the predicted. Okay. So for the accuracy, this is the computation: true positives plus true negatives over true positive plus true negatives plus false positive, false negatives. But don't worry, Python has got us covered because it's already being computed in Python. We just need to call the accuracy function to provide the accuracy. So this is actually mathematics. That's why most of the most of the data scientists are coming from computer science, physics major, ano pa ba? Engineering, because they have a lot of mathematics. So they understand the questions behind how the logistic regression is working behind the scene. So I have here some codes that we can play on. Okay. I hope you can also look at it. So you just need to click. Where do you will be clicking? So you will be clicking here on this one, the notebook, and then you will proceed to the logistic regression. So you will be proceeding to the logistic regression uh, notebook. Okay. So let me explain this data set. Okay. So this data set is a binomial or binary problem where you want to classify if you can play outside or you cannot play outside. So there are different kinds of their outlook, different kinds of outlook. We have the sunny, overcast, rainy, and yeah, so we have three. Don't have access to the notebook. Kindly click again, please. Okay, so I have here a small data set, and what I did here is actually increase the value of the data. So I use the one hot encodings for the sunny or the overlook column, because in logistic regression, we need to transform our category values into numerical. Everything should be numerical. Okay, so that's why we performed one hot encoding. So what does it do is it will transform this outlook to three columns. So it will have outlook sunny, outlook overcast, and outlook rainy. So from the original data, if it is outlook sunny will have the value 1, and outlook overcast and outlook rainy will have the value 0 for the three columns. So that is how it, so basically, let's say I will open up my Excel just to visually explain it to you for the meaning of one hot encoding. So let's say if you have a overcast or overlook column, so you have sunny, you have rainy, you have overcast. When you perform your one hot encoding, what will happen is overlook sunny, overlook rainy, overlook overcast. So instead of having one column, you will have three columns. And for this row, since the value is sunny, you will have the value 1 and to the other columns 0. So since this row is rainy, you will have value 1 in the rainy column and the others will become 0. And overcast, since this is sunny, this is 0, rainy, and overcast 1. So this is how one-hot encoding transforms our categorical values. So for the logistic regression, we really need to transform the category values into numerical values. That's why we need to perform one-hot encoding. And this code tries to update our data using PD or pandas dot get dummies, okay, data, and then the column outlook and windy. So also for windy, let's say windy has, okay, let me just put windy here. So windy has true or false, right? Something like that. So if that's the case, for the one-hot encoding, it will just transform this one into 1, 0, and 1. Okay? Or sometimes this will happen. Windy true, okay, so sometimes this will happen. So this is the transform outcome coming from these columns. Now we will drop the play because play is our target. So we will drop that from our X input. So that's what we are saying here from our explanation. Uh, let be some X feature. Yan, sinasabi dyan. So these are going to be our features and we will exclude play because play is our target. And we will use play the target to become our Y because Y is our prediction. Okay, so that's what we're going to do there. And we're going to generate more values because how many is this? 2, 4, 6, 8, 10, 12, 14. This is just 14 rows and we want to make it around 300. All right. So afterwards, after the duplication, when we play this code, this cell, we will have the weather data set. Okay. So our weather data set can be seen on this files, our folder, and over here is our data set, our weather data set. So this is around 3 pages of data. So you can see overlook, overcast, overlook rainy, overlook sunny, and windy false, and windy true. And then our target is play yes or no. So that is a classification problem. Now we need to input that on our data frame, weather data set, for the split and the training test. Okay, so what is happening here is that, let me just have my paint. So in classification, let's say you have this data set. Let me just create a circle. So if this is the totality of your data set, you need to get 20% out of it. So if this is your data set, you need to get the 80% for training, and then you will have 20% for testing. That's why we need to split for training and testing. So the meaning of 0.20 here is that you will just get 20% for the testing. That is usually the case. Now, you have a random state of 42, meaning you will get the training and testing values in a random state or a random order. That will prohibit us from having biased data from our data set. So what will happen there if we split our data into 80-20, you get the 80% and then you get the 20%. So training goes to the model. Okay. So our model is logistic regression, right? So training will go to logistic regression, our model. Now your model will have a knowledge afterwards. After training, your logistic regression will have some kind of a knowledge. Then it will test the test set. Okay. And then we will result to we will have the accuracy. We need to know the accuracy of our model. So we need to train it with data, and then the logistic regression will test the data 20% and know the accuracy. So this is what's happening. We we determine our x and y. We determine our features x, and then we have our y. Then we split it with 20 and 80. As you can see here, there is x and there is y. So our model is logistic regression. So logistic.fit, and we save it to logistic variable. So now our logistic variable fits the X train and Y train. So this is fitting the model, and the model is learning from the data. Now, this logistic predict predicts the predicts the data set or the test data set and tries to know the accuracy. So that's why we have here accuracy, precision, recall afterwards. Okay. Then we print the accuracy. So let's run the program. So our accuracy is 85%, our precision is 9, our recall is 87, and our F1 score is 88. To average the performance of our model, it seems that is our model is acceptable around an average of 86 to 87%. Okay, so that's how good our model is. Next is, okay. Okay, let me just job dump logistic. Okay. So don't mind the code below. Don't mind that. I just got, actually this is just the same code from above. So we can actually delete this one afterwards. Okay. So let me delete this one. Okay, so we will be using joblib. Joblib will wrap our model so that our model can be used for production, or we can use it for classifying the other data. Okay, so we have here a dump of logistic regression model from our training. So it has, we can say that this is already pre-trained. So when we do this, let me just separate it from a new cell. So once we do this code, we will have our logistic regression model.pkl here. So this PKL here, or our package, our model, can be reusable even if we don't train it like this all over again. So let's say you want to stop your training and then just use the package, that's okay. That will be okay. Or we don't need to retrain it all over again. So here in this one, we have our new data. So this is our new data. Let me just save this one. So let's say this is the new weather data.csv. Okay, I'm going to separate this code. All right, so that it will not run the same with this cell. Okay, so we generate a new set of data. Let's play and then save it here on our storage. So basically, this is our new data. So in real world situations, you will have new data and possibly you don't know what are the classification of this new data. So using our model that we trained, uh, logistic regression model.pkl, using that model like this, we can load our new data. So new data equals that's not ano ba yung ginamit natin? Read underscore CSV. Read underscore CSV. Of course, we need to place the name of the new data set here. Let's just rename this one to X test, something like that. So it will be the same with the argument. Oh, what happened? Let me just see. Okay. So it restarted. Let's reconnect. What happened there? Did we lose connection? Okay. So since pwede mangyari yan ano na mawala kayo, you lose connection. So good thing that we have here our package, logistic regression model package. So what we will do now is to load that here and using this code, we load it and we also load our new data, new weather data, and then now reuse that model without retraining it again and predict or know the classification of each inputs from our data. So it says yes, 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 yes. So we can play outside yes, yes, yes. Okay. Can we do a it's a data frame. So let's say if we have a new value, so a new list, ano ba yung list na pwede? 80, 0, 1, 0, 1, 0. Yan. So, na-predict niya na, no? Okay. So, print niya lang yung prediction. So, given this data set that we have, this new data set that we have, we can predict. So, paano pag meron tayo ulit bagong data? Let's say, let's create a new data over here sa baba. Pero let's say, isa lang siya, no? Kasi ibig sabihin nun 5 eh. So, let's say the temperature is 20, humidity is 100, the outlook overcast is 1, 1, 1. Okay. So if this is the case, so we will just use it on our predictor, no? So new weather data set na yung pangalan niya, pero isa lang, tingnan natin yung result. Tama naman windy true, windy false. Teka, save natin. Hindi. I-load ko siya ulit, yung pickle. May kulang ba? The feature names should match those were passed during fit. Feature names in fit yet now missing. Unnamed 0. What? Teka lang. Temperature, humidity, overlast. Feature true. Temperature, humidity. 1, 2, 3, 4, 5, 6, 7. Tama naman. 1, 4, 5, 6, 7.
Sir, hindi po kailangan i-import ulit yung library pag na-disconnect. Kanina po na-disconnect po kayo.
Na-disconnect?
Opo.
Hello?
Kailangan po bang i-import ulit kapag nag-reconnect? I-import yung library, yung module, yung si import job lib.
Teka, ito? This one?
Opo.
Let me just look at it. Oo, kapag ka na-disconnect ka, kailangan kasi you need to run this one time for it to work, yung joblib na function. Pero in this case, akin, ang error ko kasi is the dataset. Nagrereklamo siya na yung mga x-axis, yung mga x features daw, kulang. Pero tama naman, ayan siya. So let me just use the same method na ginawa ko dito. So meron siyang comma, 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 comma. May comma naman siya. Dito, comma. Overcast, comma, comma, comma. Comma, meron naman. Save ko lang siya, no? Save ko lang siya. Lagay ko lang underscore 1 or underscore 2 para tapos i-load ko na lang din. So i-load ko na lang din siya. Pero ang pangalan niya na is underscore 1. Underscore 2 pala. That's it. So let's run the code. Ayun, tumama. So I think gusto niya lang i-save muna sa CSV file. I-save muna sa CSV file bago niya i-predict. So yan, nakapag-predict na siya ng yes. So ang use case nito is kailangan nakasave muna yung ipapapredict natin sa CSV file, something like this. Then ipipredict niya yung, meron isang kulang, isang row, yung row 0. Ayan. Okay? Any questions? Any question, by the way, any question?
Siguro
Para
more sample pa,
ma-clarify.
sir.
Doubts, confusion, sa code.
Siguro another sample pa siguro, sir.
So kung yaro, gumawa tayo ng bagong data dito sa Excel. Make sure lang na parehas siya ng parameters para ma-detect. So, i-download ko yung sample. Kunyari ito, download ko siya. Kasi we have to be careful with the ayan. So we have to be careful with this thing. Ito kasi yung in-error niya sa akin kanina. Itong blanco na to na 0. So meaning, kunyari ang temperature naman niya, mamili tayo ng data dito sa dataset natin na ang answer is no. So from our CSV file, pili tayo ng no. So that is 85 daw. 85, then ang kanyang temperature ay 85, ang humidity niya is 85. Tapos ang outlook niya overcast is 0. ang kanyang rainy is 0, ang kanyang ano is sunny, and ang kanyang windy is false, and ang kanyang windy true is 0. So, pag sinave natin to, and we upload it here, okay. Ensure that your files are safe elsewhere. Okay, no problem. So our new weather data set is, ayan na siya, 85, 85, 00, 110. So, okay, okay na siya. Na next is, ipapapredict natin siya dito ngayon. So we will have a new code, something like this. And then we will just copy this one. So we will read new weather data underscore 2, which is this value, 85, 85, 00, 1110 that we just uploaded. And then we will also load the model. Actually, pag na-load nyo na siya, pwedeng hindi nyo na siya dyan ilagay kasi na-load nyo na siya kanina eh. Now, we will just use this to predict, and hopefully this is no. So let's see. So it's yes. Okay. Meaning we commit an error. So let me just print the value of x test. Okay. What if the value is what if we change the value of humidity to around 120, something like this. So therefore, our x test will change, right? So our humidity becomes 129. So let's try to predict. Still yes. Let's look at a new value. Bakit nag-yes pa rin? Kasi meron tayo talagang error. It's just 85% accurate eh. So coincidentally, nakikita natin yung error. Na-encounter natin yung error na yun. So hanap pa tayo ng no. 80-90. So let's change this one. Our temperature becomes 80. Let's check. Our humidity how to close this? Our temperature is 80. Our humidity is 90. Sabi doon kanina. Ay, nagdadagdagan. Teka, humidity should be 90. Humidity 90. We need to drop. So sabi dito, ang no daw is 7191. So baguhin natin siya. Ang humidity will be 91. 71 ang kanyang temperature. Tapos, ang kanyang overlook rainy, windy falls, windy yes, tsaka rainy yes. Okay. So babaguhin natin yung overlook niya na uy, may something wrong. Wait lang. Yan, tinanggal lang natin yung temperature will become 71. Tama na, 91. Tapos yung outlook sunny, so yung outlook sunny, copy natin to, gawin natin siyang 0. Tapos windy, gawin natin siyang 0. Yung windy true, gawin natin siyang 1. And then yung kanyang outlook rainy, gawin natin siyang 1. Okay, so now let's test. Yes pa rin. Kailan siya magminog? Supposedly magno-no siya. Teka, i-run natin to ulit. So our accuracy is 85%. I-dump natin siya and gamitin natin siya for the new data. Yes, yes, yes. Wala bang no dito? To my logical standpoint, yung temperature is sunny, windy. Ay, teka, sunny, windy. Try nyo nga i-test kung ano yung magpapalabas sa no. Kasi mataas ang temperatura, humid, sunny. Tama, gawin natin sunny, mainit. Diba? O rainy, ang rainy 0. Yes pa rin. Tingnan ng no. 71. Mababa ang temperatura, 71, malamig. 95 yung humidity. Then, umuulan at umahangin. So dun siya nagno-no. Pag umuulan at humahangin. So I think possibly din na bumabagyo nga. Oo. Pag yung temperature mababa. So nagkakaroon siya ng error kapag mataas yung temperature, scorching na yan, no? Siguro 100 mataas yan. Tapos humidity. Pwede ka pa rin maglaro basta hindi bumabagyo. Parang yun yung ibig sabihin niya eh. Okay, so meron pa rin talaga tayong error na 85% because of that. But yun, nakita nyo kung paano yung nangyayari. Nakakapag-predict na siya, di ba? Press 1 if you're ready. Hello, everyone. Okay. All right. So excuse me. Let's have another example before we go on with the hands-on tasks. Let me just go to our files. Let me just get maganda ba tong fish? Bream, roach, paddle, perch, smelt. Titanic. Ito maganda. Survived. Ayan, may survived tsaka may no survive. So let's try to use the Titanic dataset. Okay. If you here is the link for the Titanic dataset. Okay. So we're going to use the same one, but instead we're going to use the Titanic dataset. Okay, so the Titanic dataset, we will start with around here. So I will give you the code on our chat box. Teka, ayaw niya. One by one. So that's the first part. And then this is the second part. So that is the code that we're going to use. So we will just going to edit the information and upload the Titanic data set here. So we will be using the Titanic data set. So what is inside the Titanic data set? Here, okay. Let me just clean the data because there are some things that are needed to be cleaned on our data. Okay. So before this, we need to do some cleaning. I will transfer some of the codes above. Like for instance, this one. We will do some cleaning first, like we wanted to know the data. So the data has last, first, gender, age, classifier, mark, survive. So I guess we cannot use last name and first name here. So we're going to drop last. So we're going to drop last. Okay. And also first. So we need to drop last and first. Then after that, we need to use this code. So this code performs the one-hot encoding. So we will do one-hot encoding on gender because that is MF. We want to make it 1 and 0. And then we also want to use it on embarked. Okay. Ay, bawal pala. So since we're done with this, I'm going to move it up. Okay. All right. Data encoded. Data encoded. Okay, so we have now more features. So our features now are age, class, fair, survive, gender, gender M, embark Cherbourg, embark Queenstown, embark Southampton. Okay, so we have new columns in our data set. So we also need to check. So our target here is survived. So we will not be transforming survived. But make sure other features should be numerical. So in our case, it's all good. Okay, next is instead of play, we will use survived and survived. Okay. Oh, wait. Survive data. Data encoded. Encoded. Okay, so we're going to use data encoded because that is what our data frame after transformation is named. So we will be using data encoded. Access 1. We will be dropping the target and then using it in our y-axis. Same thing, we need to split using logistic regression, training the model, prediction, and then the results of the prediction. Okay, let's run. not a number. So let's check. Okay, so we have an error here. So the error is input X contains none. So what does it mean? Our data set has a none. So in order to remove that, we will also use this one, data encoder dot drop NA. Okay, encoded pala, encoded. Okay, then let's run the code. Meron pa rin. Okay, maybe we need to put here data encoded. All right. So we have an accuracy of 76, precision is 8, recall is 6, F1 scores. So if you will try to ask me, is our model good? If I'm gonna rate this, it's around 80%. 76 point something is around 80%. So I can say this is a fair result. So let's now try to save our model. Let's save our model and time a copy. Where is it? Okay, so we will be removing all of the we will be so here in this one we need to know the columns So the columns are age, class, fair. So we remove this one, age, class, fair, survived. Gender, gender F. Gender M. Queenstown and South Hampton. Okay. So we name this one new data, new Titanic data. So we will also rename this one as the Titanic model. Okay. Now next is next is we need to put some values here. Oh, sorry, we need to see the value. Where is it? Where is it? Ang gawin ko na lang, kuha na lang ako dito, no? So, kuha na lang ako like this. Tapos, save ko siya sa Excel. Ganun na lang pala gawin ko, no? Save ko na lang siya dito. Right? Yan. So, meron siyang value. Ito. 0, 1, 2. Okay. Wait. Ayan, yan na pala. So, tatanggalin lang natin yung survived. So let's try to remember na lang. No, yes, no, no, yes. So no, yes, no, no, yes. So delete natin to and then save natin siya as new Titanic dataset dot, ba't ganun? Wait lang. File, save as. It should be a CSV and new Titanic data. So load natin siya dito. Okay. So instead of using this one, new Titanic data na lang na galing sa Excel. So new Titanic data na galing sa Excel. Okay? So ano siya? No, yes, no, no, yes. Oops, ano nangyari? Ganun. Tingnan nga natin yung X-test. So X-test, kailangan daw natin same na same. So X-test, anong laman ng X-test natin? Ito, may unnamed. Unnamed? Ano ba itong unnamed na to? Kunin na lang natin yan. Save na lang natin. So, dot to CSA. Ba't parang sumobra naman? May unnamed zero. Ah, okay. Okay, napalitan. Sige, i-run ko muna to. Then, wait, sabay-sabay. Tapos, ito. Ito. Bakit ganun? Tama naman yan. Ulit, salo lang, last. So, ito yung X-test. Ano yung itsura ng X-test? Madami siya, no? Okay, tapos instead na ganito gamitin natin. Ayan, so kapag predict na siya, no, 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 yes, 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 no, 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 no. So pwede na natin siyang i-save ngayon. Nakalimutan ko yung axis 1 kaya pala nagkaka-error. Ay, axis 1. Tama, di ba? Axis 1. Bakit ganun? Ulit. Kaya, ay, teka. Meron ko ba to? Pero yung X-test, pwede pa din. So meaning, yung X-test, which is ito, so yung X-test, new data, pwede natin siyang gamitin dito as new data. Ayun. So since ayaw gumana ng save sa CSV file, pwede natin kumuha na lang tayo dito ng sample sa X data. para makapag-create tayo ng new data. Then if you want to edit it, for example, gusto mo siyang i-edit, yung new data, na yan, baguhin mo lang yung values. So for example, yung age naging 8 point. So kunyari yung age, check muna natin yung 128, 27, 128. So meaning 1 and 0. 1 and 0 or can be considered like this. Tapos age equals 20. Kunyari ganun. What's it mean? So Teka, kuha na lang tayo kayo ng isa. No? Ayan. Ngayon, yung one new data na yan, baguhin na lang natin siya, no? Kunyari, ang age niya is 20. Ano siya? Ooh, bago na. Yun. Okay na. So, one new data. Pwede na natin siyang malagay dito. Tapos, ito. So, yan. Okay. Do you have any questions with that? So, kunyari, babaguhin natin yung gender. Ay, naging 20 lahat. Naging 20 lahat eh. No? Kuha tayo ulit ng bago. Nagiging 20 lahat. Lah, ano nangyari dito? Hmm, wait lang ha. Run ko muna to ulit. Tapos, yan. Tapos, iLock. Tapos, 20. Nagkakaroon lang yung age, no? Tapos, empty yung iba. Pandas. Pandas naman. Ah, I see. 127 pala dapat. Ayun. So, yung one new data, gamitin natin dito sa baba. Ayun, no. Okay. Questions? Any question? So, i-remove ko na lang yung iba. Hindi kailangan. So, ideally, ang ibig sabihin nito is nung nag-model tayo dito sa code na to, ang ginawa natin, kumuha lang tayo ng isang sample sa X-test natin, which is yun yung new data. Kumuha lang tayo ng isa. Then, binago natin yung age, 20. So, kung gusto natin, baguhin natin yung class. Class niya is 3. So magiging class 3 siya. Tapos check natin sa classification. No pa rin. Ayun. Okay? So how can we increase the model's accuracy of 76? Okay, so the first assumption is that with few training data, our data set might provide small accuracy. So ideally, if ganito yung problema natin, 76%, pero nagre-respond naman siya sa model natin, mababa nga lang 76, kailangan pa natin i-increase yung training data natin. So, ang isa-suggest natin diyan, kuha pa tayo ng marami pang samples of data. Then, i-retrain natin yung data natin. We will retrain our model until it reaches a good estimation. Let's say around 97%. That's pretty good already. 98, 97, something like that. Okay, so now, after we have here the example in our Titanic dataset, I would want you to go to session 6, module 7. So I would want you to experiment using the logistic regression here on the breast cancer dataset. So the breast cancer dataset is located on this link. You will just need to click on the link. You just need to click on this link and you will go to the UC Irvine Machine Learning Repository and please download the data. So there is also information on the metadata that some of its parts are categorical. So you need to also clean the data to make sure everything is numerical. Then next, since we're going to use logistic regression, in your experiment, it should not be lower than this range for the accuracy. For the precision, this will be the range. So that's the estimate result using logistic regression model. Okay? So ito yung check ninyo, parang parang checker ninyo. Dapat yung accuracy ninyo hindi magfo-fall down sa 94 up to 98%. Okay? Because this is the baseline model performance. All right? So that will be your activity for the rest of the hour. And then we will try to resume around 5:30 for your result. Okay? Any mic on?
Yes. So this is what I did for the accuracy and precision. And for the sample data, I just did some random uh, sets. And for the prediction label, here's what happened.
Are you speaking right now, or you're just using the video,
Yes.
your mouse? I don't know. I can't hear anything. Okay. Can you speak? Can you present again?
Can you hear me now, sir?
Yeah, yeah, yeah. Now I can hear.
Okay. So a while ago, this is what I did for the accuracy. I just I just copied what you did a while ago. And then here I just did a random sample for the prediction label. This is what happened.
Okay, I see some little issue. You are using X test on predictions equals loaded models dot predict X test. So it means that you are using the data from your test features instead of the random sample that you created test data. But however, still correct. So what you did here is just instead of the random sample that you created, you kind of use the X test. So that's still okay. So it tells us that some of them are uh, benign. B means benign, and M means malignant. So B, M, M, B, B, M, M, M. So basically, you were able uh, to classify from the given X test. Correct. Perfect. Sure. This is still. This is also okay. All right. So you can stop sharing your screen now. Thank you very much. For the answer of Michelle, you got 87%. Okay, for the accuracy. Hmm. And for Alex, what is the accuracy? Do you have the accuracy here? Hmm. Okay, so the accuracy is 96%. Okay, I think that's great. That's great. So let me share to you again my screen. Okay. So according to the data set from your results, you should be able to get accuracy around 92 or 93 until 98.6. So if your accuracy is falling from this range, surely everything you've done is correct, because this is the benchmark or baseline model performance using logistic regression for the data set. Okay. So how did this happen? Because this data set is a very old data set. It's donated around October 31, 1995. And a lot of people already tested it with XBoost, support vector classification, random forest, neural networks, and logistic regression. So that's why they were able to provide a mean or an average score for the accuracy. Yeah. So yeah, just what I said, 93 or 92.3 until 98.6 is the sweet spot for the accuracy of logistic regression. For the precision, it's 91.55 to 98.57. Yeah, correct, correct. So I see also the result of Marlon, correct? Yeah, sure, correct. So this meeting, we were able to successfully implement logistic regression for classification. So two things that you are able to accomplish from the previous meeting, you were able to implement linear regression and then an upgrade version, which is logistic regression for classification. Yeah, so that's the end of our session for today. Okay, so what are your thoughts? Are you happy that you were able to do some machine learning for this session? So you this that's actually the start of becoming a data scientist. So actually, just to give you a story, um, a real world story of the value of becoming a data scientist as soon as possible. So actually, I have a full-time job where I am a faculty or college professor. So I've been teaching computer. I've been teaching data science for almost 7 years already. I have a lot of students that were transformed into data scientists, data analysts from those past 7 years. And now, good news, while browsing opportunities in the job search applications that I installed in my phone, I came across to this job where I will become a data scientist. And guess what? It's flexible time. It's flexi time. My boss is from United Kingdom, di ba? Soon you will be like that as well. You will get the job that you want. The job is the salary for the job is 1.5 GBP per month. Do you like a salary which would pay you 1.5 GBP a month? That's the reason why you are trying to upskill, diba? You are trying to penetrate data science, to change or career shift to be a data scientist and whatnot. So that's a cool story. Soon, when you get ready to create your own machine learning algorithms, I mean, develop an application based on machine learning algorithms, you can find jobs something like that. right? If I'm going to ask you a question, what is your expected career or outcome after the course? Would you like to also have 1.5 GBP as salary a month? If you try to equivalent that in our currency, that will be around 100,000 pesos a month. But since it's flexible time, you can still do a part-time job aside from doing it, right? So what if you have two jobs that would pay you 100,000 a month? So that will be 200,000 a month, right? So I hope I motivated you to I motivated you with this one that you will feel like there is a value out from this learning. Yeah. Hello?
Yes, sir. That's really inspiring, sir. Thank you.
Yeah, I'm not actually boasting with the success that I had now. I'm just I'm just telling everybody that before I was learning data science for the reason that I wanted to finish my PhD, not actually wanting to work in the industry just to finish my. It's a requirement. I need to study data science because it's a requirement in PhD for computer science. And guess what? This made me achieve to have a job which it's really hard, to hard to look for. 100,000 pesos. That's actually tax free because that's not in the Philippines. It's not in the Philippines setting. So according to my agreement, they will not be uh, that they will not be what do you call that? They will not be getting a deduction for tax. So that's full. Yes. 100,000 full. But the caveat, there's a catch. You will only be your salary will only come once a month. That's the catch. So you will be waiting for a month before you get your salary. But once you get your salary, you have a lot of money. So our project's basically creating something like a chat GPT platform, something like that. That's our project. So I am the data science lead for that project. So as of the moment, I'm the only data scientist in the company, but after 3 months, we will do have an expansion. So probably I will be the one to handle the bigger team for that project. I will be the one to handle the bigger. So after 3 months, if you are if you like practice a lot and do well with data science, after 3 months, we will be looking for new people to be part of the group. So the bigger picture here is to create the company's own chat GPT, something like that, a text generator application. Okay, so do you have any more questions for today's meeting, today's session? No more questions? Do you have any more questions? As early as na-apply na ako ng internship sa company siya. Pwede. Pero wala pa talaga. Kasi I will be working on the back end part of it. Until then, the company will not yet hire new people. So, junior data scientist yung mga siguro i-hire nila. Siguro ang part ko lang doon is to filter the people that they will be hiring. Parang magiging hiring manager na rin, ganun, parang something like that. Sir, send po namin sa Slack yung resume. Ay, you know what? Saan maganda mag-apply? Bigyan ko kayo ng idea, no? Saan kayo nag-a-apply by the way ng trabaho? Bago ko sabihin. LinkedIn. Okay? Good. Ano pa? Meron pa ba kayong alam na iba pa? Seek. Hindi ko na-try yung Seek. Job Street Upwork. OLJ. Okay. Guess what? Ang daming mabilis mag-reply sa Indeed.com. Ako mas marami ako nakikitang offers sa Indeed.com. Tapos ang maganda pa dun sa Indeed.com may mga reviews yung mga tao dun sa company. Nire-review rin nila yung nagpo-post ng jobs. So may rating. For example, isang company dun, ang rating niya mababa. So hindi na ako magpapasa dyan ng resume. Parang ganun. Tapos ang lalaki ng salary na nakapost dyan. Tapos nakikita mo kagad sa Indeed yung yung full-time, part-time. Ang dami ding part-time dito sa Indeed. Tapos nakikita mo ko siya kung tawag dito. Flexible time, night shift, mid shift, kita mo siya. Kasi sa job street hindi eh. Ang nakikita mo lang sa LinkedIn kung ilan yung nag-apply dun sa position. So, pinagko-combine ko siya, LinkedIn tsaka Indeed. Pero sa Indeed talaga, nagre-reply yung mga tao. Talagang mabilis ang proseso pag sa Indeed. Siguro ito yung pinaka-favorite na platform ng mga employers. Ayun lang, no? So, I think we can call this a day. If you don't have any more questions to our class, thank you very much for attending the session for today. I hope you liked the session. I hope it added some knowledge to you, right? So the next meeting will be session 7. Session 7. Hopefully, at the end of the session, we can create our portfolio, our own application that you can tell your future employers, this is the portfolio that I was working on. Parang yun yung tulong ng mga boot camps like this or specialist course like this. na hindi lang matuto yung estudyante, also to have a portfolio after you finish the course. So that's the goal, the end goal of the session. So we still have more to learn around session 7. So stay there and just wait for the the next topic to be presented on our next session. Thank you very much. Have a great weekend. See you next session.
Thank you, sir.